Doug Thompson here. We're in the shop, and I'd like to talk a little bit about the horizontal bender that I built. A viewer asked, hey, could you do a little bit more video on the horizontal bender? So that's what we're going to do today. So this is a horizontal bender that I built about 3 years ago, and I'd like to talk about first the structure and then the operation. The hydraulic cylinder is here. I think it's a 10-inch by 2.5. It produces at 3,000 psi about 25 tons, 50,000 pounds of force. Again, oriented horizontally. There is a top table out of 1-inch plate, and there's a bottom 1-inch plate that forms the primary bending structure. I purchased 3.5 by 2.5 DOM, drawn over mandrel tubing that has no seam, and that forms the basic pockets of the machine. I had the steel company burn out holes in the plates, both of them, and then I welded in this DOM tubing. That forms the structural component of holding the plates together. So the basic machine has 6 pockets, 1, 2, 3, 4, 5, 6. And oftentimes I'll put, if I'm bending a really heavy bar like this, I'll bend it against these 2 cylinders. And what I've also done too is they're open, the hydraulics are below, so I've got this little magnet, and when I am not using a particular pocket, I just made this little cover that sits down like this to keep all the scale from dropping into the inside of the machine. Below, we have the tank, the motor with the pump in the tank, the main hydraulic valve, and then a little electric box for connecting all of the electrical stuff. We're in front of the machine here, the working side of where I'm at, and here's the little control panel. We have an on-off switch, pressure gauge. I have a speed control here that I don't use a whole lot. And what I did is I had my friend Bud, he designed all the hydraulics, but he installed a very precise valve for controlling the movement of the cylinder. And I've put a palm guard here, so you can place your hand here, wrap your fingers around the handle, and then you can very precisely control the movement of the ram. And then additionally up on top, I have a little pointer here that I painted red, and I've got a scale here. But when I want to bend something repetitively, I can go to a certain portion on the scale, stop there, return, put a new part on, and then repeat the process. So there's a great deal of accuracy built into this machine, both in terms of the scale and in terms of the control and the quality of all the hydraulic components. So I've got the machine set up to bend something fairly heavy. This is a rectangular section, 1 by 2. I'm going to bend it the hard way. This is the easy way against the narrowest dimension. But if I roll this down like this, I'm going to bend this material, this 1 by 2 material, the hard way. I'd also like to talk a little bit about the neutral axis, which is in the center of the bar. When we bend, more or less, this half will go into tension, this inner half will go into compression. And that's kind of important to understand when you're bending, because if you bend too much with some material, you can tear the material on the outside. But anyways, I'll go ahead and bend this piece of 1 by 2 hot rolled material the hard way. I'm gonna go ahead and start it up, and I'll bend this a little bit. So the machine does a pretty good job of bending this solid bar. I have a pretty high degree of confidence that I could put a piece of 2 by 2 square solid there and bend it. I couldn't wrap it on itself, but if I had to do a gentle bend, I could certainly do it on that. I've bent this material. This is kind of expensive material for me. I'm gonna go ahead and turn this around and straighten it out. So all I'm gonna do is I'm gonna flip it over, put it back against the pins. I'm gonna make sure I'm in the center, and I'm gonna bring the machine forward and I'm gonna straighten that out. So there's an example of bending and straightening a bar the hard way. So I'll demonstrate a couple of different bending procedures. Right now I'm just going to do a single point bend. I'm just going to put this piece of 8x2 up to this die, and I've got a good relationship between the thickness of the material and the opening of the die. So I've got my nested tooling in here, and I'll make a 45-degree bend. So now I'm going to do a bend, counter bend to put a little wave in this bar and try to do it relatively precisely. So I'm going to look at my scale here, and I noticed when I did the single point bend that I was at about 640. So I'll go ahead and turn the part over. I'm going to place it against the far end of the die, and I'll bend to 640. Now I'll turn it over and I'll repeat that bend to 640. I'm going to engage in the far end of the tooling and then bend to 640. I'll do it one more time. So one of the things that I have to do is bend parts that are all exactly the same. Single point bend, and I've got to make them all precisely enough, both of the legs. So the way I do that, I've got this little stop that moves. I've cut all of these pieces to the same length. I want to register off one end precisely each time. That's why I've got to stop. The stop moves a little bit in case the material scrubs a little bit. I'll go ahead and place it there, and then all I'm going to do is use my scale to bend to a certain number. It's cut the same length. I'm bending to 645 on the scale. So all of these pieces will come out with this leg being the same and this leg being the same. And that's how I do precision bending with this bender. One of the issues of bending material is sometimes it doesn't matter, you might have some tool marks on it, but if tool marks are an issue and you've got a certain material that you don't want to mark up, then I'll protect the material with aluminum, wood, or plastic. So what I'm showing here is some custom tooling that I've had to make for specific jobs. I had a job where I had to bend some 1/4-inch aluminum, and it was really tall. This is a die setup to reverse the bending process. And by putting this on the front part and this on the pin, I can bend in such a way that I'll still be bending in the free space in front of the machine. This is a very specialized tool I made. I had to bend some scrolls, and I had to use this to give myself enough clearance because the scrolls were already bent. So that's a special piece of tooling. This is just a small, I had to have a certain bend geometry, so I made this tool. This one is kind of a double-sided tool for really sharp bends in thin material, and then I can also turn it over and use this side for a given bend geometry. And again, this is an extension to the standard tooling that allows me to weld different things on the front end depending on the bending problem that I face. So thanks for watching. I know I covered a lot with this, and if you have any specific questions about it, leave it in the comments section and we'll try to address this and any other ones that you have.